Beepy beepy. Hi, I'm Andrew Armstrong and welcome to the Backfist Teardown Lab. You might remember this from my last video. Not particularly this circuit, but this whole holding something down. Oh, look, there you go. It does hold it down very securely despite me yoinking it off like that, just to show you. It was really holding it on, but I decided it was time to use a real-world kit so that we could have a scenario that was more likely that you're going to try. And I did buy this thing. And this is the X001 DPIMS Soldering Products DIY Electro Microcontroller. What? Electric chip microcomputer and car. A car? Well, it doesn't look like a bloody car, and it definitely wasn't a car that I ordered, so it's not a car. I can guarantee if you ordered this thinking it was going to be a car, you'd be disappointed. Right, I'm going to tip it out onto this piece of metal. Now, one thing I did notice, it's not totally flat, so maybe I should bend it a bit. Hang on, let me just do a little... Yeah, look at that. Yeah, absolutely did nothing. Let's not worry about that then. I'm going to get out all the pieces. That's okay. I could flip it over to the shiny side, but that might not work with camera. So it is, believe it or not, some sort of ranging kit where you plug it in and it will detect a range. And it will show you on the screen how many centimeters or inches or something. Hang on, where's the screen? Oh yeah, over here. Some units of measurement. As usual, there's no instruction, so we're just going to be working out as we go along. So the first things first, I'm going to organize this, and is using some camera magic. So you can see I've assembled everything in front of me, and I've used two of those clippy things, magnetic bulldog clips, to hold the board down, and I have bent them up slightly so that there is a clearance underneath. So you can see I can put my finger, so it's about 1 centimetre under there. So first things first, I'm going to mount these components here because they go inside the microcontroller's socket. So let's start with the crystal. It's got a 12 megahertz crystal, so that's quite interesting in a not very interesting way. 22 picofarad capacitor. I'm going to pop that in there like so. And there's another 22 picofarad, and again, whoops, it's gone underneath. There's no instruction, so I'm just literally going by what's written on the PCB, which is kind of neat if you can do that. 4K7, so that'll be one of these. So if you don't have a meter, I'll tell you the colours. That's yellow, purple, red. That's what you want, some yellow, purple, reds. So I'm going to put that in. And I can see already that I haven't really got this high enough because the component legs are still way longer than what I've got set up. So far my little helping hands aren't working too well, but I've got a trick. I think I'm going to try something. So that is those components. Again, you can't quite see how far they are in because of parallax, but trust me, they are all sitting well above the board, so I'm going to push those down properly. And in order to solder those, of course, we would have to flip the board, which is a little bit tricky for some of them, but we do have a quick, like a little get out of jail for some of these, because you can top solder as well, because you can see you've got through hole vias on this PCB and they're nice and big. So I'm just going to get the components that are easy to do that way first, then I can flip the board. So you can see I can even just do one leg of these. So you can do one leg of those capacitors and resistors. You can see that's pretty much done now. And that allows you actually to turn the board over and do the other bits. But I do know that this crystal is going to try to jump out, so I'm holding that with my thumb and forefinger. I'm going to just put a piece of solder quite near it like that. And then I'm just going to drift that in across the board. And I'm using some nice 0.8mm solder today. I remember I misordered last time, got 1mm, and 1mm is crazy massive. If you're doing anything, try to go smaller, 0.8, maybe even 0.3 if you can get it. And now I can put this back into my little clips on the bench. You can see there nicely. And then just tack those other legs in. So far, so good. Now, do I think these are better than the helping hands? Yeah, definitely. The crocodile clips on the helping hands are definitely a pain, and this works pretty well. And while I'm at it, why don't I take the side cutters and just trim those. Now I have damaged these. These are genuine Xeon ones, but I've tried to cut something too thick with them and damaged the blade, so it's all munched up. I should probably try to do something about that. We've got nothing to lose at this point, but maybe we can refile the edge. That would be handy, wouldn't it? Be able to restore your side cutters to their previous glory. Yes, that's good. Let's turn it over and have a look at what other components. So that's not too not too easy. No, that was easy, just not too difficult. Now we can get that IC socket in there. So if you're building this kit or any similar kit, try to aim for the lowest components first. So resistors, small caps, passives. You know, I've gone for that electrolytic. You normally wouldn't bother doing the electrolytic till a bit later. And now I'm going to apply again my clip in a different way. Oh, that works super well. The clip is actually holding the socket from underneath, allowing me to tack the pin in. So I'm just going to do that. Go, and you can do the other corner, the opposite corner. Now I know it's not in all the way, so what I'm going to do now is just take it out. You can see, oh, it's at a funny angle, but that's okay, because all you do is just hold some heat onto that pin, apply some pressure, and it'll all push through nicely. Don't push it too soon though without applying the heat, otherwise these little bits of tin will fall out and you'll have to really poke them back in. Now the rest is easy because everything's aligned. Let's see how quickly we can do this. I imagine it's going to be blink and you'll miss it. Oh, maybe not. Maybe if we applied some flux it would have been. Again, there is flux in the solder. You might not have to go nuts. I rarely, in fact never, apply flux on a kit like this. It's just not worth it. Just make a mess for no good reason. You don't need it. And I'm going to do a little bit of a treat. I'm going to do one side with the 0.8, which you're seeing now. And let's try the 1mm solder on the other side, because you can see I have to feed quite a lot of this in. It melts really easily because it's much thinner, but you can feed it. Now this, in comparison, looks side by side. It's like a massive piece of wire. It's very rigid, very inflexible, can be a bit tedious, but you only need a tiny bit. Look at that. Look at how that just flows though. It's just dropping it in. And look at how quick that is. Boom. So now technically we could, hang on a minute, I think I've made a mistake here. So we have a microcontroller going in here. How's it supposed to go in over that? Oh, okay, so there you go. Let's correct that mistake. I'm going to try to heat both legs and see if I can just bend it a little bit. So as you heat the legs, it's going to pull it out of the PCB as you're turning it. But again, these are through-hole wires. You can see it's not going to get that bend. And I really don't want to force it. So I'm going to actually work on that a little bit more. Again, I want to really let it just push through now at this point. So it's almost as if you're trying to remove that component. Ooh. Oh, what do we think? It's probably okay. I think we're going to get away with it at that. That's fine. But what I'm going to do, you can see from the top there's a couple of little blobs there. I'm just going to, heat those. Because I want to make sure there's no stress on that component now. So that will take out the stress in the joint. And it should allow for us to put in the chip, which is an STC89C52RC. And I think we decided that these were a Far East, I don't know if it's really a clone, but something similar to a PIC. I'm just going to bend the pins. Look at that. Make sure the pins are nice and straight if you can, or as straight as you need them to be. They don't have to be perfect, but they do have to go in. And one little trick is, if you can get one side in like that, you can normally just apply a bit of pressure to bend them enough to let you get the other side in. And then you end up with something like that, and then just work that down. and check it. The last thing you want to do is really crunch it in and bend a leg. Got the resistors in now, and I have to say I'm kind of flummoxed a bit by this kit, because I've gone through and I'm totting up the components, and I've got way more components here than it's going to need. So there's a buzzer here, for example, and there's a couple of extra transistor type packages. I think I've got the same switch. I wonder if it's the same package for a different kit. One of the weird things is it's got a battery thing. I don't remember having a battery thing in the picture, but I could be wrong about that one. That one I'm not sure, I have to admit. But I do remember it said something about USB power, and it's got this USB to DC jack, so it should be 5 volts. And if you use that battery snap with that configuration, you'll get 4.5 volts of power. So I guess anything over 4 volts will probably run this. I forgot my chip bender, so my component bender, so that bends my little legs on things. So I did throw them in manually, and you can see you do have this problem of alignment, and I've kind of messed up some of those because of it. So if you do have a 3D printer, I don't know where you get the model on Thingiverse, but there is a model for a nice component leg benderer, and that will sort you out. So let's hit these now. Let's get in there. Again, I think we're going to go back to 0.8 for these. Stay down. That one doesn't want to stay down. Oh. Yeah, I'm going to have to invent more risers for these so I can get them where I want them, but that's fine. We don't have to worry about it too much because it's going to be pretty much fixed now. Boom. Yeah, that board is held nice and firm. I do think this system works. I should patent it as the Magnatech construction system. TM. Patent pending. There we go. Let's push those through. Flip it over and look at that mess. Look at that mess, but that's fine. We can keep track of it. Let's do this. Got a fair few legs to chop off as well. We'll know if we've gone wrong because we'll end up with too many empty vias on this PCB, and where there should be none. I'm pretty much sure that all of these will be filled in. Okay, I'm gonna have to chop those off in a sec, but let's do something else before. That's boring. Screen. Yeah, let's. Oh, I think before we get that gratification of the screen, we should probably figure out what transistors we want. So it says, no, actually there are 4 transistors, and it's all 9012s. So I was lying to you. Maybe there isn't too many components. Maybe I'm going to figure this out. So it's not quite the right footprint for those transistors, but it's fine. These are kind of good when they do it this way, because the wrong footprint allows you to really wedge them in so they don't fall out when you flip the board and you want to solder them. I'm not seeing a buzzer footprint. I see an LED. Is that the buzzer footprint? He was talking rubbish. Absolute rubbish. The only thing that's left over out of this is two 4K7 resistors and one 1K resistor, which I'm not going to complain about. Right, where are those components I just put in? Yeah, they're right in the middle. Can you spot them? Of course you can. Let's just hit them there. It's like a jungle now. Get through that jungle of component legs. You got this. So what do you think? You tempted so far to get one of these? Oh, I think I'm at the point where I might actually have to consider cutting some of these legs. Never. Keep going. Haven't you done a time and motion study? Putting down the tools and swapping the tools is what costs the time. Keep going. Right. There is actually a machine in the PCB construction world where you put the PCB through and it, like a blade, will just cut all those off. Isn't that groovy? I'm just going to bunch them up out of the way. Okay, right, now we can put the screen in. Now the screen does have a way round. Can you see how? Yes, the decimal points. You don't want the decimal points at the top because that would be madness. Decimal points at the bottom, like in the diagram. What? Even that is crazy. So you've got, look at the pins here. So you've got enough pins for that, but you've got too many pins for that side. So you've got 5 pins there, but 6 holes. So yeah, I don't think you can get it wrong, but if you do put it in and it looks a bit wonky, you probably really ought to undo what you just did. Start again. How do you do that though when you're designing a footprint for something and design it wrong? They probably had a footprint that uses up, there's probably an extra decimal point that they're not using on this kit, and they're using the same footprint that they have for it. That's probably all it is. It's probably not the footprint wrong necessarily, sort of. I mean, you know what I mean. Right, let's just get those done. I'm almost tempted to see how far we can take this with the whole not cutting the pins. I think let's just keep going. Definitely, if you're making it, cut the pins as you go along. It's getting quite unwieldy with pins. Right, so this is the tallest component by far. So we don't want to fit that. And I'm just having a quick scan because I do have a couple of 22 picofarad capacitors. And I really don't think there's a footprint for them. We do have battery contacts there though, we did find those, that's nice. Let's pop the switches on. And hopefully we can do those all in one go. So that switch is pretty loose, that kind, but these kind really bite in. They are not quite square, they are rectangular, so they do have a way. And I will zoom in so you can see that way. The way is with those little bits of metal widthways. You can see it's rectangular, they're the long end of the rectangles, put it that way. And they've designed this footprint quite well. Normally they're a bit tight. In fact, any that I've designed, I always have them a little bit tight and have to force them in, but at least they stay in, which is good for hand soldering. Probably less good if you're assembling them on a production line and you have to make 1,000 of them. That would be considered very wrong. So I think what we're going to do is solder in these 3 because we can just get to the edge on them very easily. And that will allow us to flip the board without worry. In fact, I'm just going to solder one leg on each because I'm going to have to hold that guy there. So I'm just going to hold this one here at the top of the board and use the little trick of putting a blob of solder near it. If I can get a blob of solder onto the end of the soldering iron. And that's the equivalent of a tack solder, well, a tack weld if you're doing some welding. Some of you are welders. I'm doing a fair bit of welding recently myself. Have you seen, by the way, there's a really cool arc welder which is self-contained. It looks like a hairdryer or a hot air gun or something, but you just literally place the stick on the end of it and all of the inverter circuitry, everything is in the handle. I really like that because it's always a faff getting out an arc welder with all the bits and bobs, but if you're doing some home welding, the arc welder is definitely the useful one to have because you can just sit in the shed for years and years between uses. You don't have to worry about gas or anything like that. So yeah, learn to use one of those. That was easy, no cutting required. While we're here, should we have a go at this thing? That is the DC jack. Now it is going to be tricky. Look, let's pop it through like that to hold it in while I tack. I think that's pretty good tack there. I'm not going to go anywhere. And I'm going to switch up to my 1 centimeter, well, one millimeter solder, 1 centimeter solder. Now you do laugh, but that does exist. That will exist in the world of plumbing and brazing. I think we're almost there. We really are almost there. Just the LED, which again, look at the picture. There's a flat edge on the LED, which is the positive. Cathode or anode? I want to say anode, but I do forget. You'll remember if it's all that you work with every single day, but not me. And of course the battery snap, because this does have a battery option. I think the battery will probably live on the back if it's going to live anywhere. So let's wire it through from the back. In fact, let's just solder it straight on. Now I know some of you like to do the whole putting the through hole bit of wire in. I don't normally bother because it just seems to melt the insulation and it doesn't really hold it in too well. So I'm just going to put it surface mount. And then it's not tinned actually, looking at it. So yeah, that's a bit of annoyance. So that one wasn't tinned, so it wasn't amazing. So let's tin this one. And tinning just means to apply some solder to the end. So you can see I've got it there side by side with the solder, so I'm just going to blob the solder on the end like that, and that's tinned nicely. I'm going to go around the back, just tack that down, and it'll be much easier. You can see how that was much easier, it just flowed straight on there. And then we do have the last bit, hopefully. I really don't see where that buzzer might attach, but let's see if we can get this on. So you have VCC, trigger, echo, and ground. Is there any? Yeah, I was going to say, is there any ICs on this? There is ICs on this, so it's doing some of the processing on this. These modules, they're available. If you have a Raspberry Pi or an Arduino, I think you can use them on those too. So there probably are data sheets available. And then the last stage now, of course, is just to cut off all those component leads and test it. We are ready to apply the magic batteries, but first it's important to tidy up. And this candy, look, you've got this, you can just chuck it away. I don't think we're going to use this USB thing, because I think if this gadget works, it's something you would want to be battery. Why would you want to be tethered to the dans la table with it? So I do intend to mount these batteries on the back here with some double-sided sticky foam, but not right now. Let's test this thing. Ooh, it's the moment of truth. Drum roll. Oh. Okay, I did try it on the USB and the thing actually worked. So I think this battery thing shouldn't be there. I think that's the speaker. So that's a big uh-oh, and that's kind of super annoying. I'm just trying to look at how else we could attach the power. The battery could probably go between some of these contacts. I mean, let's figure out first which contacts. I think that's the positive. You could put the USB power on and buzz it out. I think the side one will be the next side, the side of the bottom. Again, it's a quick test, it'll be fine. Nope. Maybe it's that one. And if I've got it totally wrong again, oh no, it's on there. Good. So let's solder suck out that and put the speaker in. Make sure you get plenty of heat on there. And go a bit quiet while you're trying to find where did you leave your solder sucker. So I'm using Japan engineering, which I don't know if it's really from Japan. Probably not. But it looks like it could be. It's got Japanese writing on it. So we've got our speaker here. It does have a positive and a negative. Very easy to identify. There's a little positive tag on there. And it should give us, this would be cool. So it gives us a nice satisfying ranging beep. And I'll tell you where that actually comes out, because I can see exactly on that component where it's connected to. So if we trace the PCB now, you can see it goes to that leg here, which says, oh, that's ground. So it's actually being driven by this IC here. So it's actually from the main microcontroller. Right, let's. All right. I'm glad I've still got the cover on that. Okay, so there it is. I'm going to turn off light. You can see it's, I think it's like a too close, can't measure it. So the first measurement is 3, about here, where that tip of that pencil is. So where would that be? So it's almost from the back of the PCB. You can't quite see it, but 3 centimeters to the back of that PCB. That's fine. 5, 6, 7, 8, 9. Oh, that's really cool. I could do without the beeping though. I've worked out what this does, and it's actually really quite awesome and useful, and you can put this in a box and put it in your garage or something. It is actually pretty cool. So what you do is you push this S4 button, the button there is the power, and you'll see that. That is the distance. So that if you come within that range, it will start beeping like a reverse sensor. So you can see I'm at 13 centimeters, and you can see when I get closer than 10 centimeters, the alarm goes off. So it's a bit like a reverse parking sensor. So imagine your car coming back. Oops, I wasn't in the plane of it then actually. Imagine your car coming back. When you get to that point, you'll hear this beep. So you could mount this in your garage. I'm not quite sure what the... Oh, the LED. Did I put the LED in wrong? I think I actually put the LED in wrong. I'll solve that in a moment. But just to show you, so example, you could hit this before, and that sets it then. And we said before, it was set to something like, 50 centimeters. So let's set it to maybe 20 centimeters. You can hear it's beeping, right? But you can imagine now a car coming out of shot here. You can see it's at 29, 5, 4, 3, 2. Time to stop. That's kind of cool. Right, I think I should tell people that I've made a deliberate mistake. A deliberate mistake has been made in every video. See if you can spot it, and then that way people can try to call me out on it, but it will seem as if it was totally intentional. And what would be fun about that is you'll be getting called out on all these things that probably aren't deliberate mistakes, but it'll be all the critiquing your soldering or something. You go, yes, I totally intended that bit of soldering to be terrible. Oh, it's just a power light. That's why it comes on, a power light. But that is actually quite useful. I like the idea of putting that in a box, and you could mount that on a little tripod. And it's like, you have to reverse your caravan or something up to your house, and then you can listen for the beep. And then without the paper, it's probably a really loud beep. Let's try it, shall we? No, we kind of need a comparison. We've got to make it beep first, though. So let's tell it to beep if you're within. Oh, there you go. Ready? Whoa, whoa, whoa! Yeah, that is way beepier that way. Brilliant. That is actually quite a nice kit. I will dig up the address for that kit and put it down below in the links, because I think Amazon have done a good one there. That's almost too good. Maybe the next thing to do is actually 3D print a nice case for that and straighten that power button, because somehow I've put it in totally skew if. Yeah, that's not good. So yeah, please comment down below if you think you would be interested in making this kit and possibly designing a 3D enclosure, because I'm game. I mean, I could design it, but hey, if you want to design it, that's even better for me. And we'll print one out for one of the future videos. But that's groovy. Thanks for watching. Please like, share, subscribe. Hopefully you find this bit of soldering useful. Come onto the Discord server and chat with me. There you go. Make it. Ultrasonic technologies, eh? Oh, before I do go though, if you're curious on how it works, I probably could use this bit of mouse receipt and draw up exactly how it kind of works. So basically you do have these doodads. Okay, and that's your ultrasonic transducer. I think that they are transducers. Now when they're used as a pair like this, you can see there's a T and an R, a transmit and a receive, so that's pretty cool. So what they do is they actually echolocate, so it actually fires out sound. So you can see sound's firing out and the waves are propagating, hitting the surface, and then they actually come back. So this is acting as a microphone and this is acting as a speaker but in ultrasonic frequencies. And what you actually do is measure the time it takes to do that. Because that actually does take time, and clearly it's a time that this microcontroller can operate within, which is cool. Or I'm pretty sure these aren't doing too many fancy things. It could be sometimes on these modules where it's doing the calculations here and then sending it, but let's see. You have VCC Trig Echo. Yeah, we'll have to look at the specs for one of these, this HC SR04 module. But either way, it gets processed. And because of the time, because you can work out the exact time it takes, that actually tells you the distance, because as this moves further and further away, of course, it takes longer, so that's a further distance being measured. And then as you get closer, of course, it gets shorter because it's getting it. But there's a point, you saw it, where it wouldn't work, because when it's here like that, the sound waves don't really have enough opportunity to bounce that way. I think they just kind of hit there and they're not really bouncing enough, or it's all getting confused, and that's why it says 00 or error, whatever it says. There you go. There. Science. See you next time. And one last thing before I go. There is something I wanted to tell you. You can test these on your car. If your car stops working, you get error, reverse parking system error. Just put your ear by these. So you see this ear, it says transmitter there. Put your ear by there on your car. The little things on the back of your car. I'm going to cover the receive so it won't go off. I'm going to hold this to the microphone and you might just be able to hear it. Ready? Maybe you heard it or not, but basically it sounds like tick, 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 tick. So that's the frequency it sends out. Tick, 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 tick.